What is quality assurance for AI? Why is it important? How can Giskard help your organization implement it in your models? Quality assurance hinges on this idea of trust. Max Tegmark, professor at MIT specializing in the intersection of physics and AI, is quoted as saying, "How do we transform today's buggy and hackable AI systems into systems we can really trust and make sure they really do what we intend them to do?" So what is quality assurance? Well, one definition is this: ensuring a model's trustworthiness through a process of rigorous testing during every stage of development. It's essentially saying we want AI models to work in a variety of situations. We want them to be robust. We want to make sure they're training on the right inputs. So how does quality assurance help? Let's take a look at how quality assurance interacts with the model development process at 5 different stages. The first stage is the problem definition stage. And the question that quality assurance seeks to help us answer at this stage is this: are you trying to solve the right problem? Cassie Kozakov, chief decision scientist at Google, is fond of bringing up a type 3 statistical error, which in her words is any rabbit hole that a data scientist goes down meticulously, carefully answering a question that just didn't need to be answered. Through a careful analysis of the problem, quality assurance and clear communication help ensure that you're solving the right problem, one that answering will provide meaningful results. The next step is the data collection step in our model development process, and quality assurance in this step helps to answer the question, are you collecting useful data? Without clean data that actually contains pertinent, profitable information, any models you train won't be able to solve your carefully crafted problem. Quality assurance helps you take a good look at your data sources and collection system to ensure that you're gathering useful data, and most importantly, the right data. Now, the next step that we want to look at here is the feature building step. And quality assurance can help you answer, are your models training on the right features? For example, in some situations, due to privacy concerns, it may be illegal for your model to train on specific features or aspects of your data. You want to make very certain that you stay away from both ineffective features and illegal features. Now, the next step in our process here is model creation. And quality assurance can help with this by answering the question, are your models finding valid relationships? You want to be able to see how changing your input parameters will affect the output of your model. If something doesn't make sense with how your model treats the features it's been trained on, you want to know so that you can have a clear plan to fix it. And the final step is the result interpretation phase. So with quality assurance, you want to know, are your results valid or are they merely spurious? If you've been performing rigorous testing through every stage of development, congratulations. You are now far more confident that your model can produce valid results. Unfortunately, quality assurance and explainable AI in general are difficult. The first issue we run into is that expert access is expensive. To make sure that your model is training on the right data, to make sure it's looking at the right things and isn't getting the right answers by chance, you have to have someone with subject matter knowledge, domain knowledge, someone who knows a lot about the problem you're trying to solve. If you're trying to solve a problem in food science, for example, your domain expert would be a food scientist. Their time is valuable and expensive, and you obviously don't want to waste it. Another reason quality assurance is tricky is because collecting the right data is hard. This is one of the main challenges with AI, knowing, do you have the right kind of data? Are you getting enough input to actually solve the problem you want to solve and not a different problem entirely? Collecting the right data is challenging. It's time intensive. You may have to combine multiple data sources to get all of the data you need for your problem. Another reason quality assurance for AI is hard is because models change when given new data. If your environment updates, like for example, maybe you're predicting stock price, so maybe the stock market has a really bad day, so your data is going to change quite a bit. When your data changes, your models are dependent on your data, so your models are going to change, and you want to make sure that your model doesn't break because of that change in the data. Another reason quality assurance is difficult is because you can't break models down into components. With a normal program, you can look at all your individual little functions and see, hey, this function does this, that function does that, and the errors, oh, it's probably over here in this function. With AI models, you can't really do that. It's a little bit of a black box in that sense. So we want to try to figure out what's going on behind the scenes without really being able to open that box up completely. Even though quality assurance can be difficult to implement successfully, it's vital to the growth of trustworthy AI systems. Recently, the European Union passed the Digital Services Act, which has pretty stringent regulations regarding transparent models. So how can you easily and efficiently implement quality assurance in your machine learning projects? Giskard is currently developing 3 tools: Inspect, which we'll walk through a demo of in just a minute, and which helps you understand the relationships going on inside your model and get feedback, and has tons of features that help expedite the process of taking a model from prototype to production. Test, which will help you convert that feedback into testing and make sure that your model is working as expected. And Monitor, which will assist in debugging models in production by providing clear warnings and possible actions. Let's look at a demo. So let's take a look at a demo of how to use Giskard Inspect. So this is just a pretty simple example on the iris dataset, which is a pretty common introduction to classification problems. As you can see, the input data here is sepal length, sepal width, petal width, and then the 5th column is the class, which could be iris virginica, iris versicolor, or iris setosa. So what we're doing here is we're just training a simple multi-layer perceptron model using scikit-learn on our iris dataset, and then we're going to print out the model score. So if I run this here, we can see that we get a model score of, it's probably going to be around, it's 0.933. So that's pretty good, but we could do better. So what we're going to do is we're going to upload it to the Giskard Inspect dashboard to see what our model is training on, what insights we can gain from our model, what things we potentially need to change. So this is what these lines of code here are doing, is we're uploading it, is we're saying here are the inputs, here's what type they are, here's what our classification labels are, here's what our prediction function is, here's what we're trying to do, in this case classification, and then we just upload that model to the Giskard Inspect dashboard. So this is what the Giskard Inspect dashboard is going to look like. If I go into my projects, click on this iris project here, then go into datasets, I can see my iris.csv dataset here. Now, if I just want a quick overview of what this dataset looks like, I can open it up and I can see the first 5 rows here. So that's really nice. If I go into models, then I can click on my most recent model and inspect that. So I then select my iris.csv dataset, select the target feature, which in this case is going to be class, and then just go. And that goes over to the inspector. Now that we're in our inspector, we can take a look at some of the data values. For example, this first one here has sepal length of 5.1, sepal width of 3.5, petal length of 1.4, petal width of 0.2, and it's correctly predicted to be an iris setosa. Now, say we want to try changing the petal length and see how that affects things. So we keep increasing the petal length, and you can see our feature contributions are changing, and if we increase it enough, now the model thinks it's going to be an iris versicolor. So that could be interesting. You might want to give feedback on that. Like, yeah, that makes sense. This should now be an iris versicolor based on our domain knowledge. So we can say, hey, yeah, that makes sense. That would be some good feedback to provide. Now we can also look at other data entries. We can, if we set this to random, we can pick a random data entry and like, oh yeah, that one's correctly predicted to be an iris versicolor. This is an interesting example of when you might want to give feedback on a particular data point, in this case entry 70, because it might be indicative of something bigger going on wrong within the model. As you can see, it predicted an iris virginica, but it's actually an iris versicolor. Something's wrong here, so we want to give feedback. Is this input case insightful? Yes, this is incorrect classification. We're doing something wrong here, and we want to know why. So if we send that feedback, and we go over to the feedback tab, we can see that other people working on this project are going to be able to see that feedback. You can see incorrect classification. Well, you might want to look at why. Like maybe look at the data point in here. So you can go back over here to the inspector, say, here's your results, here's your explanation, here's your input data. Maybe try changing things in here, see what happens. So this has just been a really quick overview of what quality assurance for AI applications entails and how Giskard can help your team to build trust in your AI models. Hope you enjoyed.